Maneesha, faculty of Chemical Engineering Department, JNTU College of Engineering, Ananthapur. So I am going to discuss about the thermal conductivity of the composite wall. So the aim of the experiment is to find out the thermal conductivity of the composite wall and thermal resistance of the composite wall and thermal conductivity of the one single material of the composite wall. So these are the aims of the experiment. Before going to the experimental procedure, I would like to briefly discuss about what is the composite wall, what is the thermal conductivity of the composite wall. So composite, we all know that the composite is nothing but made up of two or more materials. Why? Because to increase the properties of the material. If in case single material, the individual material have different properties. When we are combining all the material at a stage, then we can increase the properties of the particular material. So that's why here we are using the concept came to the composite to increase the properties of the material. In the experimental, in the laboratory, in this experiment there are three materials are mixed. That is cast iron, bakelite and the press wood. The cast iron is an example for the metal and the bakelite is example for semiconductor. Press wood is example for the insulator. When we are combining all three as a single material, by combining, then we are going to find out the thermal conductivity of all the mix of the three materials. So this is the experimental setup. This is the composite wall made up of the cast iron, bakelite and wood. In between all these materials, they are arranged with heater. There are two set of materials. Top one is the cast iron bakelite wood, and the bottom side is the cast iron bakelite wood. In between, they are set as a heater is set in between the two set of composite walls. We all know that the conduction type of heat transfer observed through the vibration of molecules. So when we are giving the input at one end of the material, we all know that the metals are closely packed elements or molecules are closely packed. So one material is completely attached to the second material. There is no way to move from one end to the another end. That's why whenever we are giving the input to the one end of the material, immediately the electrons are absorbed those energy. They are trying to move. So there is no space to move from one end to the other end. So immediately the vibration occurs. So because of this vibration with one molecule to the another molecule, the heat is transferred from one end to the another end. That is the concept of the heat is transferred from the higher temperature region to the lower temperature region through the vibration of molecules. That is briefly of the conduction type of heat transfer. Coming to the equipment description, this is the composite wall made up of three different materials, cast iron, bakelite and wood. This is called as a control panel. Where we can control all the experimental procedures, where we are getting the temperatures of all the temperatures of the equipment. So this is the heater, this is the process variable from nothing but the temperature of the at particular time. This is the set value, then we are setting the value to the system, and this is the digital temperature controller where we are getting, where we are where we can display the temperatures at different points of the system. So this is the channel changer. Coming to the experimental procedure, first we have to take the initial values of the experiment at time t equal to 0, that is nothing but without giving input to the system, we have to take the values from at time t equals 0 from T1 to T8. T1 to T8 are the temperatures of the composite wall. At the interface temperature of the heater and the cast iron, that is called as a T1. The interface temperature of the heater and the cast iron on the bottom side is called as T2. Likewise, the interface temperature of the cast iron and bakelite is T3. The interface temperature of the cast iron and bakelite is T4. The interface bakelite to wood T5, T6. At the surface T7 to T8. These are the interfaces temperatures of the composite wall. Coming to the experimental procedure, initially we have to take the values from time t equal to 0, and then we have to switch on the heater, and then finally we have to switch on the stopwatch. For every 1 minute we have to take the values from T1 to T8 up to steady state value. When we call it as a steady state value, there is no change with the previous value, then that is called as a steady state value of the